Okay, so here we have the next question on the menu today, and it is asking us, how do we find the surface area of a trapezoidal prism? Okay, so here we have on the left here a nice diagram of a trapezoidal prism. It's just a trapezoid that is like extended in to become a prism. Okay, so a lot of the times when you're trying to find surface areas, it is a very good move to try to like unfold the 3D object and find just the sum of all of the surfaces individually. So if we try to unfold this, kind of looks like a takeout box, right? So have you ever ordered like takeout in plastic, paper boxes? Kind of is what it looks like. But if we were to unfold this, this is what it would look like. Okay, so we got trapezoids like this. And between those trapezoids, we have, a rectangle between them. Then we got rectangles like this. And maybe another rectangle like this. Okay, so maybe I'll do some color coding on the sides here. So you see this red length here, and this red length. I know they don't look like they're to scale, but just keep in mind that they got to be the same. So these red lengths are the same. These green lengths are hopefully fairly clear that they're going to be the same. And the blue lines, if I switch to my blue pen, and these blue lines are going to be the same as these blue lines. And these purple lines will be the same as these purple lines. Okay, so given that you have this diagram, you can see that we have 6 sides to this trapezoid. Let's name them like A, B, C, D, E, F. Essentially, what you're going to try to do is find the surface area of these shapes individually and add them all up. You can see that the two E's are the same here. So to find the total surface area, let's call that SA for surface area, is going to be A plus B plus C plus D plus 2 times E. Okay, and that's going to be the total surface area of this. Another distance to keep in mind is maybe with the orange is all of these lengths are going to be the same. Okay, all those orange lines are the same. So we know that A is just going to be orange and blue. And those are just going to be multiplied together. Actually, A, B, C, and D are all going to be multiplied by orange. B is going to be green. A is going to be light blue. C is going to be purple. And D is going to be red. Okay, and those are really just rectangles, fairly easy, base times or like the length of one of their colors multiplied by the length of their other color. Fairly straightforward. Now the only thing that might be a little bit tricky is E, the area of the trapezoid that is making it up. But areas of trapezoids, it's really not that difficult. So if I were to draw just a trapezoid on its own like this, Okay, let's call this H for high and this one L for low. Suppose that you're only given this distance right here, and let's just call this side S. What you really want here is the height. So this will be lower h. Maybe instead of h up here, we'll do a, just so we don't get the h's confused. This h will be the same as this h. And let's call this SR for the right side and SL for the left side. So essentially you're going to need to solve for h somehow, some way, but once you get like h, it'll be quite easy to solve for like SL and L. So keep in mind that these are right angle triangles, and the area of this is going to be equal to A plus L, so the shorter side on the top plus the longer side on the bottom. We're pretty much just going to average them, because this is really just going to be a parallelogram if you rearrange it and all that. So we're going to take the average of the top and the bottom, so add them together, divide by 2, and multiply it by the height. Okay, it might take some time to solve for the height if you're not given it explicitly, but most of the time you will be given your height explicitly, and then you'll just need to solve for the SL right here. So you know, you can use Pythagoras theorem to give SL or SR, and once you have that, you can find the area of the trapezoid, and then you just find the area of all the rectangles that are associated with making it a prism, add them all up, and then you are chillin'. You are chillin'. Okay, so they have a equation here that is pretty much following the same procedure. Like you got to find all the side lengths, all the sides individually, and then you need the area of the parallelogram. I mean, not the parallelogram, the trapezoid itself. And once you have that, you got the final surface area, and then you're all good. Awesome. So yeah, the above solution is good. Most of the time you'll be given most of the information that you need, like A, B, C, D, and H, and L. So you know, if you're given all that, it really is something very straightforward to handle. Okay, cool.